Back to Further Solutions Academy. On this video, I'll be walking you on mathematics, which is a special function. I've told you earlier that a function is the same thing as mapping. Now, outside of this video are constant function, polynomial function, rational function, factorial function, and genetics function, not genetics function. By the end of this video, you will understand this type of function. Now, you know what is called constant function. You know, that is, we're talking about, it means when something is constant, f of x equals to constant c. If, for instance, f of x equals to 3. This is a very good example of what constant function. It means that function cannot move anywhere, no matter how you set this to be. Now, it can only move when you have it in form of what? Polynomial function. Now, look at this. For instance, f of x equals to minus 270. It means f of 2 still remains 270. No matter how you set it, it still remain how you set it with. That is what is called constant function. And the next one is polynomial function. Polynomial function, I've explained that this polynomial is one that covered all the type of equation. It can be direct, which is simple equation, which is simple function. It can also be linear function. It can also be quadratic function. It can also be cubic function. It depends on what you are working on. Now, polynomial function, we're just like polynomial is always like this. We have something like how will I set it up? I think I can say that what c of n, the x raised to the power n, and so. But the leading coefficient and the leading degree matters a lot. I think I will explain that when I get there. Now, when we talk about rational function, it's also like we are talking about something like rational can be in form of division. When you have a partial fraction, you know, partial fraction is a very good example of rational function. For instance, f of x equals to x plus 1 divided by x squared minus plus. You know, these are very good examples of what rational function. Now, factorial function, you know, is a very, very nice part of mathematics, which is application part of mathematics, which we'll be talking about. We all know what is called factorial. When we say that what our r is equals to what 1.2.3 to what to r himself. This is a very good example of what factorial function. Factorial function is always in a multiplication in what it can be in descending order. Please take note of that. For instance, if I have 10 factorial, for instance, 10 factorial, it means 10.9.8 and so on to what? To where we are coming to. Now, and the last one is what? Genetic function. Genetic function, we said something like it can be p of r equals to, is a mixture of factorial and integers. Factor of factorial and real number. That is genetic function. By the end of this video, you will understand all this. Don't forget to share among your friends and subscribe if you have not subscribed before. Now, let me keep the ball rolling and go along with definition and examples. Okay. The first one explain we are to talk about what is it called? We'll talk about constant function. Now, constant function, I've explained that to you. Now, a constant function of the function x equals to constant, where c is a constant. Take note of that. Is a constant. Okay, is called function. That is to say, we can set f to infinity. which is also give what? The same value. Now that is, it means when you set up anything, it will return to where you are coming from. That is what we are talking about. For instance, if I have h of x equals to 2, h of x equals to 2, this is a very good example of constant variable. For instance, my f of minus 2 will still remain 2. My f of 100 will still remain 2. There's nothing we can do. Do you get me now? It means we are talking about something like this, and we are talking about like this. Now, I can have 1, 2, 2, 3, 4. This is how this thing is being set up. It means it will give us 2. At any given setting, it will give us what? 2. It will give us 2. That is what we are talking about. It means that since it's directed to 2, everything directed to 2 is a constant function. Now, example, I think I've given you very good example of constant function. For instance, if I have f of minus 382, this is a question on it. Now, it will also be 2. F of x plus 2 will also remain 2. That is a very good example of what? Constant function. Now, let's move on to what is called polynomial function. Now, polynomial function is just like, let me put x there. Now, polynomial function is a very simple one. Now, how can we define polynomial function? Just know that anytime we set a f of x to be c of n, s raised to power n, plus c of n minus 1, s n minus 1, plus, and I think I'm making that sense, plus I will set like this. Now, it means it runs to a large number to what? C of 1, x of 1, plus c of naught, s raised to power what? Naught. Now, that is what is called, now, I can answer that what? Okay, I just want to say something now. When n is non-negative, integer, or non-negative integer. It must be integer, it must not be real. It can be, real is a collector that collects all the numbers, but integers are commonly used number minus, those numbers are integers, like minus 100 is integer, 100 is integer, but 0.77 is not an integer. Now, that is just, this must be integer that can never be what? Negative. If it is negative, the story will change. If it is negative, it will change to what? Rational function. Take note of that. Now, what you just need to know is that when you talk about polynomial, you must know what is called degree of the polynomial. Degree of this given polynomial, take note of this. Degree will just be what? The highest degree. The highest degree, which is going to be what? Degree n is n. Take note of that. My degree is what? Is n. Now, also the leading constant. Because my c of n is the what? Leading constant. Or leading coefficient. Sorry, let me use the word coefficient. Coefficient. Please, it's a leading coefficient. Now, that is all about that. For instance, if I have something like this, my f of x equals to 3x squared minus 8x plus 2. It means my leading coefficient is what? Is 3. And also degree what? Degree 2. Now, that is very, very important. And for instance, if the function change f of x equals to 1 all over pi minus 3x squared plus 2x cubed plus x cubed, I mean x raised to power 7. Now listen to me. This time around, the story has changed because it's not in the proper arrangement. Now, the leading coefficient now, degree what? Take note of that, is in degree 7. Please take note of that, degree 7, because this is the highest degree. Now, and also leading coefficient, is what? Is 1. Take note of that. Leading coefficient, because coefficient of this one is 1. And there are many more of them. For instance, if I have g of x equals to what? 2 all over 3x. Now, it means degree 1, and the leading coefficient, leading value is what? 2 all over 3. Take note of that. And also, if I have, I'm just trying to break down our polynomial function, but if the story changed, f of x equals to 2 all over x cubed. Please take note of this part. Take note of this part. When you have something like this, the story has changed. What happened? This not polynomial. Not a what? Polynomial. Because this particular one, it will be what? F of x, it will be equals to 2 x raised to power minus 3. And I've told you that it must be non-negative integer. It must be non-negative integer. That is number 1. Number 2, okay, that is very, very important. The n must be non-negative integer. It means not a what? Polynomial. Another thing that I want to show you there is that now when you have g of x equals to root of x, please take note of this particular one. G of x equals to root of x. This also not polynomial. Please, not polynomial, because I can easily write this as well as x raised to power 1 all over 2. And I've told you the condition that what? It must be non-negative integer. Is an integer. 1 all over 2 is not an integer. Take note of that. 1 all over 2 is not an integer. It is an decimal number. Decimal. Now, number 1 is a decimal. Number 2 is an real number. It's also a real number, which also we can call it a rational number. Take note of that. Please, this condition is very, very important. Very, very important. That is what we need to know about them. Now, okay, can I move on to the next one? Now, let me try to explain what is called quotient function, which is also known rational function. For instance, without going far, this is a very good example of quotient function. This is a very good example of quotient function. But let me try to explain that. Okay. Okay, now I think you can see mathematics is nice here. Okay, and you'll be fine with us. Just note that. Just note that. Since you are not lazy, because you must practice. As you have units, you must practice them. If not, you won't get the result. I need to work on okay, function that is quotient or polynomial is also known as what? Now note function that is quotient polynomial is also known as what? As rational polynomial. I mean rational function. Now that is what you just need to know. I've explained that to you that when you have f of x equals to 2 all over 3x cubed. Now this is a very good example of what? Quotient polynomial, which is also known as what? Rational function. That is what you just need to know. It's also known as what? Rational function. Now when we talk about rational function, listen to me. Rational function is just like rational function. what you just need to do, function, what you just need to do is that rational function are function that what? My f of x can be equals to what? S squared minus 6x divided by what? S plus 5. Note, my x must not be equals to what? 5. S must be not to be equals to 1. When my s equals to 5, there is a big problem. The big problem is what? The number will not exist on the number line. The number will not exist on the number line because it will be what? Undefined. It will be undefined. Please take note of that. Take note of that. Can we say that this is a very good example of quotient function? Yes, it's a very good example of quotient function because not defined, which is this with me. For instance, if I set this to be minus 5, for instance, if s is equals to 5, if s is equals to okay, it must not be minus 5. Let me put a minus 5. I think I didn't do it very well. It will be minus 5. If this is minus 5, it means that number will not exist on the number line. And I've told you that there are different type of roots, which is, let me go back to roots. Roots. Now, we have real roots. Now, real root are roots like this. Take note of this. There is a root, there is a root. There's what is called equal roots. Equal roots. Now, equal roots are roots like this. Do you get me right? Now, no roots or complex roots are roots like this. Sorry. Can you see there is no roots? It means anytime you're having, what are the numbers here? Numbers here are known as what? Real numbers. Take note of that. Real numbers. Now, real numbers, these are real numbers. Do you get me right? Now, why this one is known as imaginary number? This one is known as imaginary number. Take note of those things very, very well. Now, I just need to understand, you need to understand that part very well. And in a polynomial rational function, since numerator and denominator are each polynomial. Now, for instance, if this one can be cancelled out, for instance, you can cancel out, it can generate that what we are trying to work on. For instance, look at this now. I have g of s equals to 2x plus 3. And is a what? This is a, can we call this one a polynomial? Yes, it's a polynomial. Since it's a polynomial, I can also call it is a polynomial. Also rational function. Do you know why it's rational function? Because I can say that what my g of x can be equals to f of this. And also I can say my g of x can be equals to x plus 3 all over 1. 1 can be found in the number line. Take note of that. It means what I'm trying to do, every every polynomial function is also every polynomial function is also rational function. That is what I'm trying to do there. Because every polynomial function, I can divide it by 1. Since it can be divided by 1, and it means that is what I'm trying to do. That's all quotient function are polynomial. All polynomial function are what? Rational function. But not all rational function are not polynomial. Please do. The converse, they differ, different. I think I've shown you a lot of cases. Let me try to show 1 or 2 cases for better understanding. Okay, the time is there. I have to do something here. Okay, I think 5. Now I have some cases here. Now I have let my f of x for 2 equals to let me just set it up like this. Now I have x and I have minus x. Oh no. I'm doing rubbish, sorry. I'm mixing up the questions. I have a lot of questions to play with. That is just the fact here. Now I have f of x equals to 1 is 0, x minus 3. Now, if minus 1 less than x less than 1, this one is if 1 less than x less than equals to what? 2. If 2 less than x less than equals to 8. Now, look at this very good function. Listen very well. This is a very good example of what? Close sets. This one is what? Close below, and open above. Take note of that. Why this one is what? Open below and close above. Please, you have to understand that. I was explaining in the last video that when you have something like this, this is a very good example of what? Closed set. It's a very close one. Now, and I think I just need to understand that statement, because all what I wrote there, it can be represented by what? I can say that minus 1 and comma 1. Please, I can write this as well as that. Take note of that. It means when you see something like this, you see this bracket, the bigger bracket which has like this, is a close, and it means close and open. Now, for me to work on this particular form, they say that is what? Is 0. Now, it means is 0. F of 0, since minus 1 less than what? It will be less than 0, less than what? 1. Now, listen to me. It will be 0. It will surely be 0. If and only if I have this. It means I am talking about 1 is there, is 0. I mean, minus 1 is there, but is 0. I mean, 1 is not there. 1 is not there. That is what I mean there. That is what I mean there. Now, and also, if I have f of 2 also, look at me, since since 1 less than equals to 2, less than equals to what? 2. Now, can you see? It means the interval is between 1 and 2. It means it is a very close set by having 1, 2. This one is talking about what? Minus 1, 1. This is like this. This is like this. Comma, can you see? That is because I'm telling you this when you are talking about your topology. You need all these statements for you to get to where you are going. And also, when you have I have minus 7. Look at this. This will surely give me minus 7. Since we are talking about 2 less than equals to 7 less than equals to what? 8. Now, it means the numbers are what? It will be open like this, which is going to be what? 2 and to 8. Now, the number cannot go beyond 8. 8 is the last spot. Also, 2 is not included. The number can be 3, can be 4, can be 5, can be 6, can be 7, can be 8 himself, but 9 is not there. That is what I am trying to work on. Now, I think, okay, before I hand up, for instance, let me try to put effort on this. I'm talking about this. Can you see? I can say that what? X minus 3. I'm setting this to be x, which is going to be what? 7 minus 3. It will surely be what? It will surely be 4. Now, 4 can be there. I've told you that 4 can be there. Now, let me talk about the absolute function. Absolute function. I think you are enjoying mathematics here. Okay. Mathematics is a very nice course. Just come and learn mathematics with us. You will surely enjoy it. Now, Okay, now I'm just trying to work on part of absolute value, absolute values function. It's a function which you all know that it must be function, absolute value function. Now, what are we talking about in absolute value? I've told you absolute value is being denoted by what? By x, which is not what? Is also x. But when I have minus 1, it also be 1. Minus x absolute value is x. But under the analysis, there are some conditions that you need to also follow up. But when you talk about, if I'm to define absolute value, it will negate out negative value, negative number. It will negate out negative number, which it will be absolute value. Now, but note that absolute value of x, will be equals to x and minus x. Note that if my x greater than equals to what is 0, and if my x less than what is 0. Take note of that. Take note of that very well. Note that absolute value of 16 equals to 16. Absolute value of minus 16 equals to 16. And absolute value of okay, now it means I'm saying that what absolute value of 16 will be equals to what 16 himself will be equals to absolute value of minus 16. That is very, very important. Some question was sent to me earlier that when you have something like this and something like this, now this is called norms. Please take note of that. Somebody sent this to me and I'm trying to explain that to the person. This is called norms, which is there are video on norms of the function which under space. Try to check on it. This is not the same thing as absolute value. Just that came to my mind now, which is you need to understand that. And the last one I need to work on factorial function. Factorial function. Now, when you talk about factorial function, you just like hope you know that my half factorial will be 1, 2, 3, 4 to r himself. Do you get me now? That is factorial function. Now, don't forget that r is 0 factorial equals to 1. Take note of that. And 1 factorial equals to what? 1 dot what is 0 factorial, which is equals to what? 1. Take note of that. And we're known that 5 factorial will be equals to 5, 4, 3, 2, 1 is 0 factorial, which is equals to what? Equals to 120. If I should get right, it should be 120. Now, and so on and so forth. For instance, when you have 4 factorial all over is 0 factorial, take note of what is a function of factorial, which you need to understand that what 4.3.2.1 is 0 factorial divided by what is 0 factorial. This will cancel this, and don't forget 0 factorial is also 1, which is that is what you need to understand that. And I didn't waste much time on mine. I didn't waste much time on factorial because I'm still going to some places. Now let me try to explain the genetic function so that I will be able to cover everything before the time before the camera time was out. Okay. Thank you, Jesus. Okay, now I need to work on genetics function. Now, genetic function, I won't say much here. For instance, anytime you have for instance, P of R equals to x factorial. Let me just x factorial 1 over 4 bracket of R 3 over 4 bracket of s minus r divided by r factorial 5 minus r factorial. Now, where r are what? 0, 1, 2, and so on and so forth. Now, this is a very good of genetic function. If I set my what to be 3, I think I'll be able to what? It means 3 factorial. I'll be having what? X all over 3, and you keep, no, let me put this one as 5, sorry. 5 factorial, so I'll be able to have it. This will also be 5. Sorry, please allow. Now, if I have something like that, it means I will keep solving and solving and solving and solving. You all know that 5 factorial is 120, which I've done that here, which is 120, and 120, and also I'll be having bracket of 1 all over 4 raised to power 3, and this will be 3 all over 4 bracket of what? 5 minus 3 is to be 2 divided by what? We have 3 factorial. 3 factorial will be 3 times 2, 6 times 1. That will be what? I think I'll be having 6, and I'll be having 5 minus, that will be what? 2 factorial. 2 factorial is same thing as what? As 2. 2 factorial is same thing as 2, which 2 times 1, 2 times 1, I think you all know that. Now, that is all. That is all. I can say that what? 164, if I want to do it, 120 multiplied by 1 all over 1, I mean 64 dot 9 all over what? 16 divided by 18, which is going to be what? 18. Let me just multiply direct. I don't have any issue. I think 4 here is what? 4 here, 4 in 12, I think I'll be having 3, which is going to be what? That will be 30. 30 times 4, it will be 120. Now, 30. And 4 here will be what? 4. Yes, 4 that is a 4. 4 in 16 is 4. Now, also, 4 here cannot divide anything, and you keep dividing and you keep dividing. By so doing that, you'll be having 45 all over 1. It means I'll be having 18 multiplied by 12, which is going to be what? 45 all over what? 216. I mean, it should be 1, 2. Is it 216? 516, sorry, 516. 516. That is what you need to work on. I think I'll be stopping here. In the next video, I'll be working on the composite function, which is a combination of functions together. Don't forget to share and subscribe. Once again, thanks for watching.